again is Mr. Jisan1, and in this video, I will explain and solve problems related to the impulse momentum theorem. The impulse momentum theorem states that the impulse applied to an object is equal to the change in its momentum. In equation form, the impulse applied to an object is equal to the change in its momentum, where F stands for force, where this symbol stands for time interval, this for mass, this for final velocity, and this for initial velocity. This theorem helps us understand how force, time, and motions are related, especially in situations such as braking vehicles or collisions. In this presentation, I will solve two real-life situations involving vehicles to demonstrate how impulse theorem works. Now let us proceed to the first problem. A car with a mass of 1,000 kilograms is traveling at 25 meters per second, which is about 90 kilometers per hour. The driver suddenly applies the brakes and the car eventually comes to a complete stop. We are asked to calculate the average braking force in two situations. First situation. When the road is dry, the stopping time is 5 seconds. When the road is wet, the stopping time increases to 8 seconds. So let us identify the given values. First, we will list all the information given in the problem. The mass of the car is 1,000 kilograms. The initial velocity is 25 meters per second. The final velocity is 0 meters per second. The dry road stopping time is 5 seconds. The wet road stopping time is 8 seconds. For the original formula, the interval time is usually here. However, in the problem, we are tasked to find the force. To isolate the force, we need to remove the interval time for this in this. Now, let's substitute all the values into the formula. We will use this formula. The first step in solving this for the dry road is first, we will need to subtract the velocities. Zero minus 25 is equals to negative 25. And after subtracting the velocities, we will move on multiplying the mass. The mass is 1,000. The velocities are negative 25 is equals to negative 25,000. And after that, we will divide that negative 25,000 to 5 seconds. Negative 25,000 divided by 5 is equals to negative 5,000. So, the average braking force is negative 5,000 N. The negative sign means the force is opposite the direction of motion. Next, I use the same formula but change the stopping time to 8 seconds. First, we solve the velocities again. 0 minus 25 is equals to negative 25. 1,000 times negative 25 is equals to negative 25,000. Negative 25,000 minus 8, divided by 8 is equals to 3,125. This means when the stopping time becomes longer, the braking force becomes smaller. Wet roads have less frictions, so the cars need more time to stop. Now that we understand how stopping time affects braking force, let us move on to another situation involving a much larger collision and a vehicle braking force. In our question 2, truck collision with a barrier. A truck with a mass 5,000 kilograms is moving at 15 meters per second when it collides with a safety barrier. We will calculate the average force exerted during the collision under two conditions. First, when the truck stops in 0.5 seconds. Second, when the barrier increases stopping time to 2 seconds. First, let us identify the given values. For mass, the given is 5,000 kilograms. For initial velocity, the given is 15 meters per second. For final velocity, the given is 0 meters per second. There are two cases. For the case 1, we will solve for 0.5 stopping time. First, we have to subtract the velocities. 0 minus 15 is equals to negative 15. And next, we have the mass, 5,000 minus negative 15, minus 15, we will have negative 75,000. And after that, negative 75,000 divided by negative 15 is equals to negative 1,500, 150,000 is equals to negative 150,000. So, the average force is negative 150,000 newtons. The negative sign means the force is opposite the direction of motion, which happens during a collision. Now, this is the equation or solution for the case 2. We are given the stopping time of 2 seconds. This is the formula. Now, we need to subtract the velocities. 0 minus 15 is equals to negative 15. 5,000 times negative 15 is equals to negative 75,000. 5,000 is from the mass. Negative 75,000 divided by 2, which is the stopping time, is equals to negative 37,500 pesos. Per seconds. The conclusion is negative 37,500 newtons. So now, if we compare the results, if the truck stops in 0.5 seconds, the force is 1,500 newtons. If the stopping time increases to 2, the force becomes 37,500 newtons. This means the force becoming 4 times smaller when the stopping time increases. This explains why safety barriers, airbags, and crumple zones are important. They are designed to increase the time of impact during a collision. When the time becomes longer, the force experienced by passengers becomes smaller, which helps reduce injuries and damage. In conclusion, the impulse momentum theorem explains the relationship between force, time, and motion. From the problems we solved, we learned that increasing stopping time reduces the force during braking or collisions. Wet roads increase stopping time because there is less friction. Safety devices like barriers and airbags protect passengers by increasing the time of impact. Understanding these concepts helps us see how physics is applied in real-life situations, especially in vehicle safety and accident prevention. That is for my presentation, and thank you for listening. I hope that you learned something valuable and you can apply this in real-life situations. Thank you, Ma'am Geraldine.